Right, so I guess we're good to get started. Right, just as a quick sanity check. So people who have their video turned on, can you wave your hand at me, please, if you've actually used a distributed system before? And we've got a few hands. Good stuff. Excellent. Okay, how many people have used a distributed database before? A couple. Anybody used Riak before? Well, again, that I'm impressed. Well done, people. Excellent stuff. Right. In that case, I'd like to crack on with stuff. Thank you for listening to my talk today, How Not to Fail at Distributed Systems. In today's talk, we're going to discover that my slides aren't turning. Let me try that again. There we go. So we're going to have a brief introduction where I wish about myself and basically what we're going to, some stuff in the talk. We're going to talk about how to plan for the worst when things go wrong, as you know they all do in IT. We're going to talk about thinking big with how your systems scale. A very important one that most people skip is don't just check the boxes. Admin purposes actually have a reason. My favorites, the art of fine tuning. And lastly, we're going to wrap up with a brief Q&A. I expect the talk will take roughly another 25 minutes from now. So we're going to move on to the start. To begin with, who am I? For people who don't know who I am and haven't seen my previous CodeBean talks, my name's Nicholas Adams. I'm the head of support at TI Tokyo. I am a 25-year veteran of tech support. Within that period, I've done support for the distributed database Riak for over 5 years. And I contribute to the open source community for Riak, both directly as a coder, and I also manage all the packages. Well, produce, I think, is probably the right word. For the people who weren't lucky enough to wave their hands at me telling me they knew what a distributed system was, very briefly, a distributed system is one that runs on multiple machines simultaneously. Data is shared between the machines. Commonly, it stores multiple copies of the data. It has some ability to scale, depending on which one you're using. And they also have the ability to process vast quantities of data. And there's a bit of background. What kind of businesses use them? We have financial institutions, and ATM is a great example of a distributed system, as they all know your balance. We have government organizations, one we may not want here, but the IRS for tax returns. E-commerce, another one for distributed systems. Amazon is a great example. Manufacturing, factory floor, pick up data analysis from multiple points on your floor to find out what's going on. And one people are probably very familiar with from this conference, messaging. For example, WhatsApp is also one of the big users of distributed systems. So now people know roughly what's going on and what a distributed system is. I'd like to go on to talk about how to plan for the worst. After all, what could possibly go wrong? And to be honest, there are lots of things. We have conflicting writes, where you have two different people in different locations updating the same file at exactly the same time. You end up with two different copies. Which one is the official one that you use? Different systems handle this differently. In Riak's case, we have something called vector clocks, and we also have an alternate situation which allows you to take two different copies and call them siblings and then resolve later in your application layer. We have network partitions. This is where, let's say, the switch connecting your two racks internally fails. Each rack of servers is perfectly fine and they continue working as normal. Both servers can still see the load balancer, so load balancers can see serving to requests to both sets of racks. Unfortunately, there's no internal syncing, which means you have one rack that has a completely updated set of data and another rack with a completely updated set of data, and they don't match. And that makes life very interesting. From there, performance spikes. That's basically a standard IT one anywhere. You hit it too hard, it falls over. Hardware failure, again, common across the board. I'm sure everybody's familiar with it. And finally, one of the biggest dangers to any IT system anywhere is humans. Now, looking through the above, I should probably make sure, is everybody here familiar with CAP theorem? Quick show of hands. 1, 2, 3, 4, 5. Oh, yeah, that's actually quite good. Right, CAP theorem for people who aren't aware of, oh, more videos. Awesome. CAP theorem for people who aren't aware of it is the concept of consistency. We have availability and we have partition. And the idea behind it is within these three different items, only two of them can be achieved at any given time. So consistency, for example, conflicting writes, corrupted data, all kinds of things would fall under that part. We have partition, network partition is the obvious one. And availability, basically anything that takes your cluster down will affect your availability, which will stop things working. And you can only look after 2 of those at any given time. With regards to availability, which would be the last 3 I talked about there, our company has implemented something that we recommend to all of our customers called the 70% rule. And I'm literally just going to read that. But basically, when a spike in resource usage regularly hits 70% or higher, it's time to add more machines. And this is very important in distributed systems. I'd like to show you an example of this in action. So, in this example, I'm going to, for people with great eyesight, you can probably just about see at the bottom, average CPU utilization per day. This is a set of servers, a 5-node cluster. If you look carefully at the graph, you'll see that they average roughly 60% CPU usage per day, or possibly just under 60%. And given your average work environment, that means you have occasional spikes up to 70% or so. Hence, 70% rule in action. Everybody got that? Good. Right, so what happens in our 70% rule? Let's say server 4 suddenly explodes in a shower of logic. And of course, pretty much stops working. What has to happen from there is you have a fault-tolerant cluster. That means that the cluster sees that server 4 is no longer available. And all the work from server 4 is then shunted to the remaining 4 servers in the cluster, which with server 4 using 60% of its CPU as its average, that means all the remaining 4 servers get a bump of approximately 15% apiece. And then server 4 is essentially gone. Now, because this is a well-designed system, it handled the failure very well, all's fine and dandy, and with the exception of the few customers who are unfortunate enough to be using server 4 at that point in time, nobody noticed anything. And as soon as the load balancer caught up, literally there's nothing to notice. So server 4 is down, but the cluster's still running fine. What do we do? Well, you know, work in IT, we think, well, probably we shouldn't really leave server 4 there forever. So we send our highly trained, we send our highly trained engineer down to the data center to go and fix server 4. So because he's highly trained and experienced, what does he do? He unplugs server 5. Because we've all done that. How many people here have unplugged the wrong server by accident? Yes. Yep, that's a common one. So server 5 has gone offline as well, and suddenly the cluster panics. We've lost 2 machines. What do we do? If you can look closely at that, that's server 5 using 70% of its CPU per day. So that 70% has to be divided between the remaining 3 servers. And because we were smart enough to plan things using the 70% rule, we're not quite redlining, but we're dangerously close. Either way, the cluster has survived 2 servers being down. Okay, a performance spike now here could really hurt it. But because it's a temporary hiccup due to the server being unplugged, it's just plug it back in again and we're good to go. So despite losing 2 servers or 40% of the maximum cluster capacity, our cluster continues to run without an issue. And of course, we're going to have people who say, well, I don't want to do that. I want to get the maximum amount of juice as possible out of my servers, go and pay money for them. So let's go ahead, let's take it out for the rule breakers. So just to argue the case, here we have servers averaging roughly 80% to kick off with. We go through for the same example. So server 4 explodes. If you look carefully, that's about 84%. 84% shared by the remaining 4 servers means each remaining server needs to add 21%. Seem fair? This is just an example. In some cases, it's even more. For example, disk I/O, if you have to shuffle all the data around the cluster, that'll probably be additional load they have to take as well. But staying with the CPU example, server 4 is dead. So we then say, okay, server 5, we'll take you as our first example. You're using 80% of your daily CPU, you add 21%. We have 101%, and server 5 starts to cough and splutter and gives up in an overall binary failure, stalls and dies because you've overclocked your CPU. So what happens by this time, if you have decent monitoring systems in place, and you really should do if you're running production servers, your alarms are going off and your engineer hurries down to the data center just in time to watch server 5 keel over and die. Server 3 also tries to take on all the service resources from server 4 and 5 and gives up the ghost and dies. Server 2 follows suit soon after. So does server 1, and before you know it, all your servers have died completely and you've encountered what is called a cascading failure, where everything gives up and soon all the telephones are ringing with angry customers saying, "What on earth is going on? All my data's gone." And you think, maybe I should have bought that extra server when we were told to. But these things happen. It's quite common. We've seen it in a number of customers, and eventually they get there, but they often have to have a few failures first. Anyway, moving on. So that's how things can break. Next one is thinking big. This is thinking about how are you ready to scale? Because growth, as people here are probably quite aware, can have consequences. In often cases, very unexpected consequences. And in possibly the worst segue in the entire conference, I'd like to take time to reflect on that mirror as we go on to talk about sharding. Now, sharding, for people who are unaware of this, is the concept where you take all your data and then you split it out between all the machines in your cluster, and they will have a little piece each. So in the same way here we have our servers represented by 4 people. And if we look at our broken mirror, we've got conveniently 8 shards there. So we give him one piece, we give him a second piece, and so on, and distribute all the pieces around, and everything's fine and dandy, and the load's shared across all the servers, and the world is wonderful. Okay, so let's say we now find the cluster is starting to become under a bit of strain. So what do? Well, we say probably we should add another machine. But we've already set the number of shards we've got, so there are no new shards. What do? Well, our new machine has to beat up one of the old machines and say, "Give me one of your shards." So we do. And there we go. Now we have everybody using things. But you'll notice the distribution has changed. We've got 3 machines, or 3 people in this case, holding on to 2 shards apiece. And we've got 2 machines with 1 shard apiece. And this is something we've actually seen in production where people scale. They find out that because they haven't considered how many shards they expect their they haven't thought how their database will grow and scale. They select too many shards to start off with, which is great for only a handful of servers. But once you get a large number of servers, you'll start to find that even though your cluster is running at maximum throughput, lots of your servers aren't really doing anything. And the reason for that is that they only have limited access to how much data they can process, which they do very easily at just over tick over. So you find out you spend all this wonderful money on hardware that spends most of its time not being used. The same is true the other way though. If we take the same example, we clear all the lines out and we say, all right, well, we don't want to under-provide the number of shards. We want to go over the top and provide a crazy number. So we now have a ridiculous number of shards we're going to share across our cluster. And already that's hard to look at. You can't quite see what goes where. And this is another problem we've seen in production where people thought, well, we don't want to under-provide, so we'll provide as many shards as we possibly can. And then the server spends so much time trying to work out which one they should be focusing on that the overhead involved there actually means the servers are already using a fair portion of their resources before they're doing anything. So this is one of the key ones here is when you shard your data, most systems that implement this, you're unable to change that, or it's really hard to change that once you put it in production. So you need to plan carefully how much you expect your database to grow before you set your shards. Otherwise, you can't change it later. You end up with either underused servers or over-allocated servers that are unable to handle the the amount of shards you've given them. Moving on. Another part I'd like to think about is interrelations. How do different parts of your application work together? So imagine taking your distributed database and you plug it into a de facto search tool, such as a project's Solr. In doing this, you can turn your regular data into super data. And this is where it gets fun. So Solr is actually really clever. It's a truly awesome setup. So Solr stores all the indexes it takes from your database in RAM. That means it's incredibly fast, but plugged into Riak, it also has the benefit of Riak's consistency and resiliency across its working place. So that gives us the ability to go on and we shall basically have the ability, and this is taken from a customer example, to index everything. For example, we can index customer's first name, we can index the family name, date of birth, reference ID. I mean, this is awesome. Everything is stored in RAM. It's really fast. We'll keep everything there just in case we need it in the future. So we index their contact details. We can even index the counter on the database of what number we put the customer in. We have no obvious use for that right now, but we're going to index it everywhere because everything is awesome. So we then take this. This is our first record. So we store that in, and Solar runs through and indexes all these different things, and it's really fast, and we're all happy and great. And this isn't currently in a development cluster, so it's all good. We have a few hundred records, everything's great, scales beautifully. So now we put it into production, we find out things are starting to grow. So we've gone from a few hundred records to a few thousand records, and it's still scaling nicely, and it's all wonderful. Then we go from a few thousand records to a few 100,000 records to a few million records. And we notice that resource usage is starting to increase a bit more quickly than we thought it would for the old memory. And we keep going. And we go through and we look at them and say, well, this is all we're doing. We're indexing contact name, first name, contact, family name, date of birth, counter, reference ID. And you sit back for a while and you go, well, counter, it's not that big, but we're not really using it. You think for a while, and you say, well, we've got this counter, and it's indexed everywhere. So it's in every single Solar index, which means it's in RAM all over the place. And we realized that by creating this counter that's never used, we've got this item that sits in memory. It does nothing, and it consumes your system resources. I like to think about that for a second. Something that sits in RAM, does nothing at all, and consumes system resources. And before you realize it, you've gone on, and your counter is not a counter. You've created a zombie. And not only do you have one zombie from each record, you have another zombie from the next record, and the next record, and the next record, until you have this army of zombies that come to eat all the RAM out of your system. You run into a huge out of memory issue, and the whole thing falls over and collapses. And this is why you need to plan what you're going to do before you get there. Just because it's cool and you can do it doesn't mean you should for production. But moving on, let's think more of an administrative level. This next section is don't just check the boxes. Now, if we think about your standard office, you have an official method of issue handling. Something goes wrong, attempted to solve it by myself. I referred to the manual, I escalated internally, I consulted an expert. The issue was resolved. Wonderful. I'm sure most of you have processes something like this at your companies. But in reality, we know it doesn't work like that, does it? Instead, let's have a look at what we believe is the typical issue handling flowchart. So, first question, very simple. Can I fix it by myself? And if you excuse a second, I just have a quick drink. So, can I fix it by myself? And the answer is yes. So, I shall solve it with my own original method. Seem fair? Yep, I can't see an obvious fault with that. I do that too. Well, let's say I can't fix it by myself. What do? I ask the person next to me. They're quite smart. Hopefully they can help. And can I fix it with their help? Well, yes, we create our own original method, we solve the problem, and we're all happy bunnies. Or no, maybe we can't. So what do? We ask an expert. That could be somebody from the community. It could be a paid support team. It could be a top person in your company. It could be anybody. We ask an expert. It's very generic. And we get our advice from the expert and we think, well, now we know what to do. Does it seem worth it? Do I really want to fix that? Seems like a lot of hard work. Maybe I should, maybe I shouldn't. Well, I know. What I'll do is I'll take the fun bits and I'll implement those and I'll use that to make my own solution. And that's great. It's a common one. Or the flip side, what I have of this is some people who say, well, does it seem worth it? It's a lot of hard work and I think we can actually live with it. So they choose to live with it, the issue is ignored, and we come to the end of the flowchart. How many people here have seen similar things implemented in companies, unofficially? Yep, there we go, a few hands, thank you very much. And we all know that once we get to this level, it's not really the end, is it? If you deliberately live with your issue, or in reality, ignore the issue, we end up with the issue gets worse. And that basically takes us back to the start of the loop where somebody a few weeks or a few months later has to come back and go, well, yeah, we should have fixed that, but it's made it worse. So how do we fix it now? And you go through the same process. And of course, that now looks like the complete one, except it's not, is it? We're missing something. Because when people cherry pick advice or do creative stuff, you haven't solved it with your own original method, have you? What actually happens, it may not be today, it may not be tomorrow, may not be a month down the line, but somewhere it comes back to bite you, where the fix that you put in, you threw together quickly, actually creates a new issue altogether. And you find yourself back at the start. And this is why people should actually go through it in a bit more detail and try to do things properly, especially ask an expert. If you pay for support, you're paying these people to tell you what to do. Don't just ignore parts of it. Try and do the whole thing so it fixes properly. But if we go from engineering level, let's go up to corporate level. Every corporation generally has an annual report. What did you do this year? Did you review the IT budget? Yes. Did you perform a full inventory check? Yes. Did you perform a health and safety check? Yes. Did you perform a system audit or health check? Usually with a third party. And the answer is generally yes. The bigger the company, the more likely this happened. But do they really get value for this? I mean, I look at how clients implement the results of a health check or audit, and I have to say, I'm very much reminded of the daily stand-up or weekly stand-up meetings that I'm sure many of you have to sit through. So what do I mean by this? Well, you have a daily stand-up meeting where people roll in whenever they're ready. One guy stands up and says, oh, this week I did blah, 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 blah. And everybody tunes out and nobody except the person directly responsible for that has any idea what's going on. Once that guy then gets bored and finishes, he sits down and the next guy stands up. Everybody else tunes out and he talks for about 5 to 10 minutes and it continues like this. And a health check exactly the same. Lots of the health checks we've seen, there are a few, at least 50 to 100, few hundred pages long, giving specific recommendations that are just not implemented. And I can give you an example of this from one of our customers. They had some wonderful hardware running virtual machines, and they deliberately over-provisioned their machines. So every VM thought that it had significantly more resources than they actually did, which means that whenever resources were needed, every machine tried to grab everything. And much like a group of small children do with a bowl of sweets, things did not end well. The thing is, though, that, oh, sorry, I pressed the button too early. The thing is, though, with that health check, things did not end well at the time. And again, even though it's implemented in the health check, and they keep writing to us, hey, we keep running out of resources. Yeah, you remember that health check we gave you 2 years ago? Tells you exactly how to fix it. And it's still not fixed. It's something people have against health checks, and I don't understand it. Yes, they're ticking a box, but don't just tick the box, actually make sure it happens, and you have a lot less issues. But from there, we're going to move on to the art of fine-tuning. And this is one of my favorites because people have some very creative solutions on how to do this. Now, the first thing I like people to do is, please give your default settings a bit of love. For example, why is that the default setting? It's not Windows. It's not on just because people complain if it doesn't work out the box. Think in more detail. What does this function actually do? How will changing it affect my environment in the long term? And I mean seriously long term, not the next few weeks. What does the manual say about this? What do the support team say about this? And taking this simple list of 5 questions, I'd like to give you a real-world example of how dangerous this can be when it's not done properly. Before doing that, I'd like to talk about something else very briefly. Is everybody here familiar with cold data? Quick show of hands, cold data. Ooh, okay. Oh, we got 1, 2. All right. That's better than nobody. Okay, cold data for people here is data that's basically not accessed for a long time. It sits on your disks for sometimes weeks, months, years. Nobody touches it. And it can be subject to a thing called bit rot, where it's sat on disk for so long, it starts to become gray of, is that a 1 or a 0? And your data slowly corrupts itself over time. It takes a long time, but it does happen. Within Riak, we have a tool called Active Anti-Entropy, or AE, which avoids bit drops happening throughout your cluster by literally going through in the background and very, very slowly reading your entire cluster's data to itself. In the read, it checks for any consistencies between the 3 copies and fixes the inconsistencies. So you never encounter this. But now you would understand the concept of what this tool does and how it keeps your data safe. I'm going to tell you the story now. So we had a cloud storage provider as one of our customers, and they were looking to save on system resources in use. So what they did was they turned this function off without telling us. Now, if we throw this back to the flowchart we had earlier, they turned it off, but it still seemed to work fine. Everything was great. So what happened with them? They had a RAID controller die. They contacted support and asked how to remedy the situation. They couldn't fix it by themselves. They couldn't fix it internally. So they escalated up to us. We told them how to fix it. We told them to replace the faulty hardware, add the server back into the cluster, and if AE is not running, perform an all partition repair, which is server resource intensive. And they decided to ignore the latter part as they wanted to save server resources. They simply re-added the server and decided everything was fine. As everything was fine, they then wrote this down in their notes as this is how you can look after hardware failure in the cluster. And this is their new official method, which, as you'd expect, will cause a new issue. Fast forward 8 months. The RAID controller on another server died. As they succeeded with their previous methods, which they'd written down, they simply replaced the server, added it back to the cluster, and did not perform the repair. Fast forward a few weeks later, a customer tried to retrieve one of their backup files, but couldn't. It would download about 70% and then time out. So we were called in. And at the time, we managed to trace the different chunks of the multi-gigabyte file and discovered that instead of the 3 copies that Riak should be keeping when it's repaired properly, there was only 1 copy as repairs hadn't been run and AE wasn't running. So there's only 1 copy for a number of chunks and empty file handlers where the other copies should have been. Thanks to bit rot or data corruption, the only surviving chunk, around 70% of the way through the file, was corrupt, so the system would time out when recompiling the file from the chunks and fail. Given a non-recoverable 1 megabit part of an essentially multi-gigabit zip file, there was no way to retrieve the customer data. Not long after, other customers started to report the same issue. And to cut a very long story short, I have to say that that client has since left the cloud storage business, which seems like a bit of a terrible loss when all of this could have been avoided so easily by simply thinking, why is that default? Wondering what the function actually does, thinking long-term how it will change their environment. What does the manual say? It tells you in the docs, if you're going to do this, make sure you do these kind of repairs. If you'd have asked us, which actually we did, and we did tell them, if you do that, make sure you do these repairs. So it's not that hard to see why changing the default setting could have very easily worked for them. But because they didn't play by the rules, they didn't follow, essentially giving the default settings a bit of love, it caused them not only to have problems go wrong, but problems to go wrong so badly they had to leave the industry they were working in. So these things are important, even though people just think, well, it's default, let's just change it quickly. It looks better if we do it this way. Don't, it's very dangerous. But I've just noticed how quickly we're running through the time here. I'd like to move on briefly to wrap up on today's talk, which happened a lot more quickly than I expected. Today, what did we do? We talked about, we discussed CAP theorem and how different types of failure affect different parts of how your setup works together. We discussed planning early for scaling all components at a sustainable rate. Key point there, sustainable growth. We looked at actually following official processes properly and to the letter. They're not just there for the fun of checking boxes. They're there to be followed because if you don't, bad things can happen. And finally, we looked at more deeply into why defaults are actually default settings. There's often a lot more thought behind it rather than, well, it just came that way. Please look in more detail before you go randomly changing stuff and risk breaking things long term. That concludes the basic part of my talk today. I'd like to move on to questions and answers. If anybody would like to contact me, my details are on the page. Yep, React support, we're going to that. Please ask me about that as well if you want to do it, or email me separately. Other than that, if there's anything else you'd like to know, I open the floor to questions now. Thank you very much for listening. If you're wondering why I'm looking at a different screen, that's where the questions things are. No, I see people offering me applause. That's very kind of you. I like the emojis. Oh, there are questions.
So Barbara has a question. Barbara, would you like to unmute yourself?
Yes, I do have a question. I love those React ninjas. Is there like a set of ninjas to use by employees, or are they being done on your demand, for example?
Oh, right. This is a fascinating question. When these used to be the property of Basho, but when Basho went bankrupt due to gross mismanagement by the venture capitalists, Bet365 bought all the IP. However, if you looked on the websites that they had back in the day, all of these were available to download and use free of charge, provided that no edits or changes were made to them, or you didn't use them to imply anything that was derogatory towards Riak or Basho. So I'm afraid we've asked Bet365 if we can have a designer make new ones, but we've not been given permission to do so yet. However, the permission stands to use the old ones if you can find them and download them. There are a few more that do exist somewhere, as I know Martin Sumner, who's a big React developer, also has them, but I don't know where he got those from, as those are ones I can't find. But there are a great set of these. There are a couple more that I haven't used here, but they're all good fun.
Yeah, super good. Thank you.
Thank you.
That is indeed a nice question. So any other questions from the audience?
Okay, there's one in the questions here. Could React be used as a distributed SQL like Yugabyte and CockroachDB? I'm not sure if you're familiar with this, but one of the projects of React that didn't quite make it into the mainstream was React.ts, where it was literally a distributed SQL database built on top of the distributed key value store React. It does still exist. If you go to the download binaries link on my slide that's currently being shown, you can actually download copies of React.ts. It's designed for time series, so it has a limited implementation of SQL, but it is there, it does work. And hopefully in the future, we can bring in those SQL features back to the main KV data store to allow you more practical usage of it. React.ts was essentially, it was production ready, but more of a semi-beta level production ready at the time when Basho went under, and not so many people from the open source community have judged working on it to be a main thing to spend time on.
We have a question from Emil Holmström. Emil, do you want to ask your question?
Yeah, sure. Hello?
Yep, hello.
Go ahead.
Yeah, so I also work with customers a lot, and I have very similar experience that you give some advice to the customer and they only listen to part of it, or they completely ignores it. And how to educate the customers, how to make them listen.
Right, that's a very interesting question. We're still working on that ourselves. There seems to be no magic bullet that covers every single case. Generally experiment with wording. First of all, we reply with quite generic text, but slowly we increase the urgency of this is caused by this is a serious problem, and so on and so on. So you gradually increase the urgency of your wording until they do something about it. One of our customers we had actually earlier this week came to us with a ridiculous issue that had been lurking in the background for years. We basically told them this is a serious issue. This needs to be audited internally immediately, possibly take the servers offline to do so, which is a bit of, oh my God, what do I do now? On the plus side, they jumped straight into it and have started doing it. So we're quite chuffed about that. You know, it's been sitting there for a good few years and they're finally doing it.
That's great.
But yeah, it's very customer specific, I'm afraid. Some customers are wonderful and do it immediately. Some take half of your advice and then vanish partway through the troubleshooting process because they think they've got enough information to fix it. I'm afraid there's no identical customers as far as we can tell.
Right, so there is some Darwinism there.
Sorry, say again?
There is some Darwinism that customers,
Darwinism.
Darwinism.
Hmm.
The customer who doesn't listen well will go out of business or may go out of business.
Yes, we actually saw that with some of our customers that haven't followed the advice and didn't read the manual, and it actually fell over. So, yep, that's very true.
I think we have.
Cloud storage provider going out of business is not a great way to lose your money.
I've got time for, I think, for one last question here. So, Aaron Gunderson. Aaron, can you
yes,
ask your question?
I was just. Hello.
Hi.
Can you hear me?
Yep. Hear you loud and
Go ahead.
clear.
Oh, cool. My question was just more, it sounds like you're dealing with like databases and support and network customers, things like that. I was curious, how do you handle technical support with customers that say like don't necessarily want to have you access to their database, or maybe that's offline on a secure, like what, do you have any tips or experience with that? I'm curious.
Actually, the way we work is we treat all customers exactly the same. We deliberately refuse access to their databases or systems. We don't want to be there. We don't want the responsibility. What we do is within Riak, there's a command called Riak debug, which will basically have Riak dump a complete set of system commands, logs, and everything else. And we just get the customer to email that to us. Then we go through all the complete outputs, look for where likely signs are of what their issue is, link to the symptoms they're listing, and then give them advice based on that, saying, well, based on this, we see this, this, and this, go implement it. And that's generally how we solve it. So whether their system is online or not is completely irrelevant to us. I mean, some of our customers are financial institutions. They will not let us in even if we want to. So we need to find a way to be able to work with people like that. And this is essentially it. We do have people who redact part of their logs because it contains sensitive file names as far as they can decide. But the system works. So yeah, just get people to send you logs. And if you have sufficient information in the logs you can use to solve your problem, that's it. Also, we ask them to run specific commands and then tell us what the output is.